I'd like to address a common mistake some people make with radicals. For example, here, if we have the square root of 3 squared plus 4 squared, a lot of people want to take the square root of each term individually and get 3 plus 4, which is 7. Now there's an easy way to see if that's right or not, and that's simply doing the math, doing your order of operations. So let's take a look at that. If we work through the arithmetic on this, we need to do what's under the radical sign first before we apply the radical, because we don't know what to take the square root of yet. Inside there we got squares and addition. Remember, we do exponents before we do addition. If we do 3 squared and then 4 squared, we get 9 and 16. So we've got the square root of 9 plus 16. That makes 25, and the square root of 25 is 5. Clearly not 7. So it's wrong to take the square root of each term individually and then add them together. Let's look at one more example. 5 squared plus 12 squared is not equal to 17. If we took the square root of each thing individually, we'd get 5 plus 12. If we work it out and do our math, 5 squared is 25, 12 squared is 144. You add those together and you get 169, the square root of which is 13, which is not 17. So here's another example that shows you that that doesn't work. Now this is something easy that you can do on your own to remember the correct way to take the square root of something. You've got the square root of x squared plus 9. Is that x plus 3? Well, clearly not, because we cannot take the square root of each term individually. We could not take the square root of the x and the 9 individually. And a way you can verify this on your own is to make a triangle with string, or by drawing something on a piece of paper. You could draw a triangle with sides of 3 and 4, a right triangle, and see if you can fit a 7 in the hypotenuse. Let's try that really quickly. So we draw our figure, and we want to know if 3 squared plus 4 squared is 7 or not. Now remember, we can relate this to another idea besides order of operations, as we did earlier. That allowed us to see that 3 squared plus 4 squared is not 7. But another way to integrate this, and that's an important thing to do, relate ideas to ideas. That makes you more powerful, helps you understand things better, get a firmer grasp. That's how we're creative. Now, this is just like the Pythagorean Theorem if we solve for c. Remember, Pythagorean Theorem says a squared plus b squared is c squared. If we get the c alone, we take the square root of each side, we get that. And then if we put some numbers in for a and b, we could get this, 3 and 4. Our triangle would be like this. A squared plus b squared is c squared. If one side is 3 and another is 4, we want to figure out what the hypotenuse is. Now, we know 3 and 4 and a triangle cannot have 7 as hypotenuse, because that would be a straight line. If the whole line is 7 and you go 3 and then 4, you don't get a triangle, you get a straight line. To go up above the triangle, or above the straight line and then back down to make a triangle, we need 2 lengths that are more than the 7. Like we might need a 5-foot piece of board and a 5-foot piece of board to span the 7. 3 and 4 will just lie flat along it. It does not make a triangle. So again, this can be seen as an application of the Pythagorean Theorem. So then clearly 3 squared plus 4 squared is not 7. You do the math, it's going to be 5. You could do this with the drawing, you could do this with string, you could do this with a piece of board. Try cutting 2 boards that are 3 feet by 4 feet and see if you can get, make sure they're at a right angle, and see if you can put a 7-foot board between the tip of one and the tip of the other. It's not going to work. You need a 5-foot board. So those are some things that you ought to be trying to do on your own to really understand math and to learn to reason properly. Unfortunately, some of this stuff is just told to us. You're trained not to understand why, just to take it as you're told. Those are bad mental habits. You really want to learn the reasons for things and understand why something is true. This is a simple example. This is easily within your grasp. So we looked at applying order of operations to, wrong side, to this. So you can see it should come out to be 5 and not 7. And we looked at relating it to the Pythagorean Theorem to see the same thing. The square root of 3 squared plus 4 squared should be 5, not 7. You could also try this with 5, 12, 13, or 7, 24, 25, other Pythagorean triples as they're called. So, hope this helped. Please be doing some of this on your own. Be thinking, reasoning, using logic, making connections, because it's very important for making yourself a better thinker and being more efficacious and practical in life.